Ora si registrerà la
You already introduced the aim of this webinar today. This is a part of a regular series that we have held in the past couple of months and which has gone with us during the lockdown phase. So we have got to know many initiatives and projects. And the projects that we host today are two projects of the so-called IoT security cluster of the European Commission, with which we work in close touch. So we look very much forward from hearing with them. I have to mention that ourselves and IoT and also many projects of the security cluster have contributed to a recently published, I think yesterday was released, book exactly on the topics on security and privacy and the different findings and initiatives of the different projects. I will post later in the chat details of this book, ebook, which is available online, so all our guests can have a look at the research findings there. I also want to thank Mirko Ross from Digital Work and Dimitri Lagutin from Aalto University, which agreed to be with us today to present their research and their initiatives and their initial findings. So without further ado, I'm very happy to give the floor to Mirko. Mirko will speak, then we will hear from Dimitri, and then we will have some time for Q&A or other interventions. So Alice, thank you very much for that. And Mirko, you have the floor.
Okay, thanks. I have also a little bit of double noise, but now it's better. I think so. Yeah, thank you very much for inviting me and presenting IoT Crawler. Just I need the rights for screen sharing, I think so, to switch then to the presentation. Hopefully it works. Very good. Very good. So I don't see the screen I need. But I think it works. Okay, very good. I hope you can see my screen now. And let me switch to the presentation modus.
Pascal, please, can you mute because you're introducing echo?
It still looks a little bit weird because you see my other presentation screen layout as well. And now I made it, hopefully. Thank you very much. Everybody for joining here this webinar, and the audio now seems also as well fine. So yes, I have the pleasure to present IoT Crawler, which is a European research project, and our main topic in IoT Crawler is search in Internet of Things. First of all, let me a little bit switch to the partners of this project and the main URL. So we have several partners across different domains in the project. So we have SMEs and industrial partners as HET, NEC, Siemens, Odins, and ourselves by Digital Works. We have city partners as well with the Aarhus community, and then the research partners from the university, which is the Aarhus University, the University of Osnabrück, and the University of Surrey. If you want to have a closer look to what we are doing in the project, just go to our website, which is www.iotcrawler.eu. So these are the partners, and I'm representing Digital Works, which is one of the SME partners. Just give you an overview what is the objectives, or what are the objectives in IoT Crawler. I mean, we have, let's say, four main objectives. One is we are looking for key assets for the future development. I mean, it's a European project, so we need big topics. But what does it mean at the end? I mean, as we know that IoT is the source of big data, and big data will be anywhere will really the baseline for every application we can imagine in the future in the IoT, like autonomous driving, smart city application, smart industry, and so on. And there will be a lot of IoT assets involved as the data sources. It's rather clear that the search in these assets and working with the data and finding the right data and even accessing the right data for all this big data driven applications in these domains, this is a key challenge. So less or more in IoT crawler, the partners have chosen it as one objectives to enable technologies which allow you to search in these data sets for this kind of different applications in the different domains. The second objective, if we say, well, this was the data objective, the second objective for IoT in fancy means there is so many things related to the data objects because we talk about IoT assets. So how do you onboard IoT assets to a search engine? If we don't think about the evil way of onboarding IoT assets to, let's say, all these hacker search engines we know out there who are doing port scanning and then just try to grab data of vulnerable IoT devices. No, we want to have procedures where public infrastructure, a company infrastructure, or semi-open public infrastructure can onboard certain IoT devices to allow crawling the data. This is one thing. And secondly, of course, we need to develop as well a description on how, from a semantic perspective, then we can include these devices with their data into this whole crawling and search engine topics. And by that related, if we, let's say, compare IoT crawler towards the Shodan approach, of course, this is all about security and privacy in IoT. If we have a look on the IoT assets and the data, we don't want to be the evil guys. We only want to crawl data, which is, from a user perspective, data where the users are giving the allowance to crawl the data, or from a application level where some certain applications have given the right, for example, to crawl a certain IoT asset within certain asset of the data. And this is important. This is important for every domain, but if I will talk later about the ways where where our use cases are located, you're getting a better overview things, I think, about the challenges. And at least because it's a research project and it's a European research project, of course, there's also the demand for novel solutions, not because of the research itself, but because of the topic of search discovery in the IoT space. Because obviously it seems to be that search and discovery in IoT currently is broken. It's not working very well. If it would work very well, there would be no Shodan. But as there are some certain problems with IoT devices towards security, privacy, I think it shows overall that we need some novel solutions to perform search for, let's say, the not harmful way to search on IoT devices, the way we need in industry, the way we need in applications like smart cities, or even healthcare. I mean, there are so many topics. And we are a European project, and by that, of course, we want to bring Europe as well forward with the project towards all the security and privacy related topics. I mean, that's a huge challenge. So the big question always with this huge challenge, how can we manage these monsters? I mean, because there are a lot of monsters we are facing there. And the best way, beside the research activities on finding really new core ideas on how we can organize search and crawling in the IoT space, is of course to work with use cases. And this is not like, because I'm not a hardcore researcher, I'm the one who is coming from the SME space. Of course, to me, even it's more easier to think about use cases because you have some practical approaches. And by the practical approaches, you can discuss what is needed for secure search in the Internet of Things. So in IoT crawler, we have 8 use cases which have been developed during the project. And now, I mean, we have started now almost 2.5 years ago working with IoT crawler. So many of these use cases are now well progressed. They are not already finished, but they are well progressed. So we know rather clearly now where the IoT crawler approach works very well. And what is needed, for example, to include the search of IoT crawler to this kind of practical domains. So just let me go through the use cases so that you're getting a better understanding where we apply search with IoT crawler. So the first use case is flexible trading for smaller sets. And this is done by Siemens. And if you look into detail, this is a lot about facility management, how to use IoT assets in facilities, in smart buildings. And this is always about heterogeneous IoT networks, because you have not only one company who's naturally providing all the IoT devices in a building. So we have a set of different devices and even a set of different type of devices which will deliver different data. So the approach of Siemens here is, first of all, as well, to have a secure search and discovery of the devices, and then as well how to perform a search inside these buildings. And there we have as well a clear security related topic, because not every device or every procedure should be allowed to search in devices in smart buildings, because this is let's say, often a case where data needs to be shared in a compartment, because a building is a compartment, and the data is used, for example, to control the energy efficiency of a building. So it's even used for processes and not only for displaying data. So there's as well a high demand on the security of the data. So the people of Siemens are working as well, not only on the semantic level, how to find the right semantic structure for this data to be searched. It's also a challenge to find, to define the right security methods so that devices can share the data with the right party. For our use case, it's use case 2, machine monitoring. We are working on Industrial 4.0 use case. There is also, let's say, a high compartment structure in Industry 4.0. This means that a lot of data will only be shared inside this compartment, and a compartment could be a manufacturing facility or could be a shop floor. And data is there needed to optimize the processes on the shop floor. And we use the data there for building so-called machine monitors, virtual machine monitors, which are leading into digital twins. And the idea is that you can aggregate the data of different machines. You can display the data there on mobile phones or iPads. And by that, the people working on the shop floor, controlling the shop floor, can search on particular data. They can, for example, find out if there's any problems on a machine, and then easily search through certain data sets, which helps them to resolve the problem. Scenario 3 are pop-up experimentation spaces. So this is inside the city of Aarhus, and there's also, let's say, Aarhus has some special places where citizens and people can deploy their own IoT applications. And when I was visiting Aarhus, I was really impressed how Aarhus is implementing citizen science and citizens toward their smart city spaces. And here we see they're using, for example, IoT crawler to enable people to build up some certain applications with IoT for geofencing. Then the scenario 4 is room booking, which is as well more to me an, let's say, mid-compartment use case. It's simple about how can we leverage IoT technology and allow people to search into data to enable room booking systems at the Aarhus University. Then we have the scenario 5, which is called Smart Connect, also by one of the industrial partners here by HET. And this use case is focusing on smart homes. And to me, smart homes are also rather heterogeneous environments. So you have a lot of digital IoT assets there. And HET is working on a use case to show how you can leverage the data from these different smart home assets. This is also rather related to two topics. One is semantic, how you can get the data in the right semantic level so that you can search on this data. And the other one, as the smart home is a high protective area as well, it's also about, of course, privacy and security. Then on Mosia, we have a smart parking use case. I mean, smart parking is one of the most popular IoT use cases you can imagine in smart cities, I believe so. And there it's just simple a question, how can we leverage from the information of the smart parking sensors to optimize the parking situation inside Mosia. Then scenario 7, which is made by the University of Surrey, is about elderly care, which is an IoT crawler just because we are dealing with elderly people in care situation. From the privacy level, the most sensitive use cases, because we are dealing here really with data which is related to medical data, and this is this kind of really high protective way of data to be used. So here we're also facing two issues. Surrey, first of all, it's a lot of data. So Surrey is really focusing on how to create the indexing and how to make it performance. And the second way or the second issue there is how to secure this indexing topics because, I mean, they're dealing with a really high sensitive way of health data. And scenario 8 is again by the city of Aarhus. I hope I said it right, Aarhus, I think so. And it's about how can you compare data? And this is as well a part of this citizen science approach in Aarhus, where people can bring in their own sensors, their own technology, build their own application, often with the help of the Things network. But you have sensor data, so you're installing your sensors in this kind of your own applications, but how you can be sure that the data your sensor is showing is really the right data, or did you make any mistakes in terms of a wrong configuration of the sensor, so it's bringing wrong data, or even like a wrong installation of the sensor. So with the help of this use case scenario, we can compare data, and then you can benchmark this data to data sets where you know they are valid. And by that, this allows you to set up the citizen sensor approach on a more, let's say, hands-on way, and even give people a support when they set up their own sensor projects. Now, this was the use case, and here is about the architecture. And as you see, well, the architecture overall has several components. And of course, this question of several components is related to all the different topics we are facing in IoT crawler. But if we have a look at this whole architecture thing, there are several components which are, I think, the rather interesting in terms of the IoT crawler project. One, of course, is the question like what we do towards indexing and ranking. Like, so in IoT crawler, we have a component which is fed by semantic data, and there's a component in before preparing the semantic data. and this is going into an indexing machine, but indexing data is nothing without ranking, because we want to make a search result which allows you even to get meaningful results for all the application which will follow up, and by that you need a ranking mechanism as well. So I would say, well, indexing and ranking, this is the core, of course, of the IoT crawler engine, and then there are a lot of, let's say, components in before which will allow even that a certain IoT domain is allowed to connect to the IoT crawler engine. So that's why we are using this kind of local brokers. We need a registry, because bootstrapping the devices to the IoT crawler engine is an important process. We have some certain analytics in behind if we want to make it rather on an automatic way. And then if ranking and indexing is together, it's all a question about how you can build your front-end applications up on this basic core IoT crawler search engine. And then we have some kind of front-end application enablers, which is where you can build your own application up on IoT crawler. The project itself, we have a project website, as I've shown you, and we have a project GitHub. So if you are interested in our results, then most of the results now have been recently published on a public GitHub. So you can go to the https github.com/IoTcrawler. And there you will have all resources which are public available. Mostly we managed inside the project that most or the most important core components are all available to open source. So you can rebuild the IoT crawler framework and you can test it with it. So we have also published some let's say use cases there. We'll just have a brief look for you in the GitLab repository, 1 second, so that you can have a look there as well. But I need to just switch to the right window. And with the support of the GitLab, I think you get a very good overview on what has been already published. But to me, the publishing is only halfway done. So what we made in IoT crawler and what will be really as well forced within the next weeks remaining is that you're getting a lot of examples on how to set up the IoT crawler within your own environment. So if you see, well, we have all the components here, but as a developer, if you want to step in, then I think the IoT crawler examples will be the core things you should have a look in GitHub. So we have now one case from Osnabrück for sensor integration, where they made a brilliant example. So everything is published here in the GitHub. Even as well that we say, come on, we have some content which is really helpful to let's make this kind of quick hello world examples. So a lot of things will be published there as well within the next weeks, but everything so you can step in easily with the IoT crawler framework. And by that, I'm happy to finish my presentation in time, and I'm looking forward your questions.
Many thanks for your presentation, Mirko. And let me say that we will get back to you since we are collecting the different enablers that the projects have been working on. So we will ask you some feedback so that we can better circulate also the work that you are doing, which is an impressive amount of work as you have shown to us. So I would do one thing. I would collect 1 or 2 questions if we have them now, since your presentation is still hot in a sense that you have just given it, and then I will move to the second speaker. Is there anybody from the floor that wants to intervene? If not, we can collect all the feedback and intervention later, and I'm happy to give the floor to Dimitri from Aalto University that will give us some info on Sophie. Dimitri, you have the floor.
Yes, thank you. Can you see my slides now?
Yes, we do.
Okay, thank you for the introductions. So I'm Dmitry Lakutin from Aalto University, and I'm working as the project coordinator in the EU Sophia project. And today I will talk about the Sophia Secure Open Federation for Internet Everywhere approach in the context of Interledger and digital identifiers and privacy. And the slides, my presentation includes the slides from my colleague Nikos Fotiou from Athens University of Economics and Business from Greece. And actually the Sophia project was presented in NG IoT webinar 4 weeks ago, where we discussed the Sophia approach and pilots. So now in this presentation, I will go in more detail to our technical solutions. So first, as the background, okay, now it seems nice. Okay, now the slides are changing. Great. So first, as the background, as you probably are all aware, the fragmentation is the major issue in the Internet of Things world, that we have a lot of closed IoT systems which don't really collaborate with each other. They cannot exchange data or actions across IoT systems. And this leads then to various problems like high barriers of entry and reduced competition. So the new players cannot enter the market because their systems are not interoperable with the existing ones. And then also we have a worse privacy, since big players force users to put their private data in their clouds and so on. And Sophia is the Horizon 2020 project that aims to provide secure open federation for existing both open and closed IoT platforms. And as enabling technology, we are using distributed ledger technologies, DLTs, such as blockchains. And the Sophia project has started also 2.5 years ago, so we are now in the final year of the project. And the goal of the Sophia is not require any changes to the existing IoT platforms, to enable platforms to work easily together with the Sophia, and also eventually enable open business platforms and open data markets where participants could easily join without any centralized gatekeeper. Next, I will describe Sophia pilots in a brief detail. So we have 4 different pilots. First pilot is the food supply chain pilot, which is located in Greece. Here, the idea is that we track and record the growth and transportation conditions of the agricultural produce all the way from the farm to the supermarket. And in this way, we can provide consumer accurate data that how exactly the produce was grown, how much fertilizers were used, was it transported with the correct temperature, and so on. The next pilot is in Italy, decentralized energy flexibility marketplace. It aims to solve the problem of reverse power flow that can occur in electric grid when there is a surplus of renewable energy production. So the goal is to provide incentives for the electrical vehicle owners to charge their vehicles at a certain time and at a certain place to use the to absorb the excess energy produced, and in this way to avoid the reverse power flow in the electrical grid. The third pilot is also related to energy. It's decentralized energy data exchange pilot in Estonia, where the goal is to allow users to give third parties access to some of their smart metering data in a GDPR compliant manner, so the user will be in a control of the data sharing, and this would in turn enable third parties to create the various applications, novel applications to the end users. And then finally we have a fourth pilot, which is a context-aware mobile gaming pilot in Finland, where the gamers who play like the mobile games can interact with the real world through IoT devices, and also the pilot includes secure and transparent in-game asset trading. So that was about the SOFIA pilots. And next, I will briefly describe the SOFIA architecture and framework. And also, our architecture is available as open source on GitHub. So there is a link at the bottom of the page. So in this figure at the bottom, we have IoT platforms, devices, assets, and so on. And then at the top, we have IoT applications and clients. And the right side, we have various type of ledgers, and I will talk next about what kind of ledgers we can have them, but they can be both public and private. And then in the center, we have the SOFIA framework composed of multiple components. And in this presentation, I will concentrate on interledger, identity, authentication, and authorization components, and also on privacy and data sovereignty. And in addition to that, the SOFIA framework contains 3 other components, such as marketplace, semantic representation, and discovery and provisioning. So next, I will start with the interledger and provide some background information about distributed ledgers, such as blockchains. So as you have probably heard, various distributed ledgers have been a hot topic in the past years, and there is a lot of misconceptions about them. But if you think about, like, from technical point of view, the main property of distributed ledgers is immutability of data. So after the data has been inserted in the ledger, it cannot be changed afterwards. And then this in turn enables distributed trust between the participants of the ledger who may not otherwise trust each other. And then distributed ledgers often have support for smart contracts, which in turn allow the high degree of automation. And there are a lot of different ledgers available, and they can be classified in terms of openness. So they can be a fully open, like public Ethereum or Bitcoin, where everybody can both read and write the transactions. They could be semi-open, where the read access is open, but the write access is restricted, or they could be fully permissioned or closed, in which case both the read and write access are restricted. And these approaches, of course, have their own trade-offs. And if you think about the real-world system, most of the DLTs will likely to be closed or semi-open, simply because using a fully open DLT for everything like Ethereum or Bitcoin would be too expensive. So the next, we can compare the features offered by open and permissioned or closed DLTs. So with open DLTs, we have a very high level of immutability and security, because these are based on the worldwide network that is using proof of work. So it's very difficult to hijack the network. It would require enormous computational power, but of course, this also leads to very high cost and also long transaction delay and low throughput. So for example, for Ethereum or Bitcoin, the throughput is like of transactions per second for the whole world. And then open DLTs, of course, are open in such a way that anyone can read transactions, which is sometimes a good thing, but it can also lead to privacy issues. So one should not put private data in immutable public ledger. And then if you think about closed DLTs, they are mostly the opposite. So we have more limited immutability and security guarantees, but then we have a low cost and low delay and high throughput, and of course the limited access to transactions. So, like, depending on the situation, it makes sense to use one of these. And so the basic idea of the interledger is that by using multiple DLTs in parallel, we can actually achieve best of both worlds. So we can use a permission DLT for situations where we need high throughput and low cost, and then we can use public open DLTs for high level of trust and immutability. And this in turn would enable much lower cost and better efficiency compared to using only the public DLTs. And therefore, in turn, we can have a better interoperability and automation. So for example, after we record some event on one ledger, we can have some another transaction on another ledger, which can then trigger some other activities, and we can tie these transactions with various things like digital payments, access control, giving access to or providing data on sensor readings, IoT actuation, and so on. And of course, the big benefit of the ledgers is immutability. So we always have an audit trail stored on the ledger, which means that it will be possible to check that what has been happened, what did happen, and why. And in the Sophia project, we are using the interledger approach for multiple use cases. The one simple use case is that we have a lot of transactions on a private ledger, and then we take a hash of the some number of transactions and then store this hash to the public ledger for non-repudiation properties. So it means that after we have hash stored in the public ledger, it would not be possible to modify the original transactions without breaking the hash. And this is like an easy way to provide immutability without putting all the transactions directly to the public ledger. And then we can also use interledger approaches to record access control policies and access control related transactions, such as like issuance of access tokens and trade assets in a secure and transparent manner, and also like perform automatic payments, for example, after the asset has been delivered, or in another way that deliver the asset after the payment has been made. Okay, so the next I will provide more technical details of our interledger component, which is available in GitHub, just like other components. So currently we provide support for 3 ledgers: Ethereum, Guardtime, KSI, and Hyperledger Fabric. And the support for Hyperledger Fabric is not public yet, but it will be released shortly. And our interledger component is designed to be modular and relatively simple, so support for additional ledgers is easy to add. And the figure on the left shows the basic architecture of the interledger component. So we have, in this example, we have 2 ledgers. Fabric is the initiator ledger, and Ethereum is the responder ledger. And on both ledgers, we have deployed the smart contracts, or which are called chain code in case of Fabric. And then we have the interledger software component there in the middle, and it is connected to both ledgers. So basically, like after we have some event on initiator, then the interledger component performs the transaction on the responder ledger, and in this way we can transfer data across the ledgers. And we also have a support for atomic transactions, which means that the initiator ledger is aware of the status of the transaction on the responder side. And then in a case of failure, for example, it can roll back transaction. And in this way, we can provide atomicity. And also the design of the interledger component is simple and flexible. So the use case specific logic, that what kind of data we are transferring, how we are handling the incoming data and so on, they are implemented on the ledgers through smart contracts, which means that we can have a different use cases without making any changes to the actual interledger software component. And the use cases that we have include, for example, asset or state transfer between multiple ledgers using hash time lock contracts between ledgers and so on. So that concludes the interledger part, and next I will move to the another topic the second topic of today's presentation, the digital identifiers and privacy issues. And by In this context, the identifiers and the certificates refer both to people and the Internet of Things devices. So we can use the same approach for both. So as you may be aware, currently the digital identifier and certificate solutions have several problems. That we either have one identifier for each service, which is not that convenient for the end user, or we can have some federated solutions like Eduroam that have only quite limited use, so they work only in certain countries and for certain use case areas, or we can use some social logins, which means that we are using Google or Facebook account to log in the services, but that leads to vendor logins that then you would actually need to have a Google or Facebook account to use this service, and there is a lack of privacy, then that single sign-on provider would know that what kind of third-party services you are accessing. And with the digital certificates, there is a problem that the certificate usually provides a lot of information, and even if we would only need to reveal a subset of information, we would need to reveal everything. So it's either we reveal everything or reveal nothing. And if we think about that, how these issues should be solved, that what would be the goals, then first we would want to have more self-sovereignty, especially for identifiers, so we would need to rely on any third party for generating identifiers. And related to this, we should be able to change identifiers at will to prevent correlation attacks, and also have the ability to disclose minimal amount of information to the service. So next I will talk about decentralized identifiers and verifiable credentials, which are novel emerging technologies developed by W3C consortium, and which basically aim to solve the above mentioned problems. So first we have digital identifiers, which provide self-sovereignty. So it means they can be created without any, they're called decentralized identifiers. So they can be created without any dependency on the third party, and the IDs are often derived from the public-private key pairs. So they have some fields in the beginning, and then we could have encoded either public key or the hash of the public key or something like that. And then we can also have DID document objects for public entities that would provide additional information about the DID holder, like how to contact the owner of the DID, what is the currently used key, and so on. And there are a lot of proposals that how to store these document objects. They could be stored on ledgers or in DNS records or on websites and so on. And then the related technology to decentralized identifiers is the verifiable credentials, which basically provide like more fine-grained and machine-readable approach compared to the traditional authorization certificates. So the goal of verifiable credentials is similar as with the certificates. It allows the subjects to present some claim about itself and for the verifier to verify that. And verifiable credentials support selective disclosure, which means that the subject can reveal only a subset of information presented in the credential. They are designed to be usually machine readable, and also some verifiable credentials support the zero knowledge proofs, which means that the subject can prove something about itself, like he is over 18 years old, without revealing a real age. And this is useful for the services which don't really need your real age or date of birth. They just need to know whether you are adult, for example, or not. And next I will talk about how we are solving these identifier and privacy issues in Sofia. So we are using the extensively decentralized identifiers and verifiable credentials for authentication and authorization purposes. And we have a principle that we have a minimal collection of personal information, that, for example, if you think about our food supply chain use case, that we have a truck delivering goods to the warehouse doesn't really need to know the real identity of the truck driver. It should be enough to know that the truck driver has been certified by the truck company with whom the warehouse has the cooperation agreement. And it's not even necessary to know wherever the truck driver is the same as yesterday or last week. And then also we support the anonymous payments for goods or services if possible. And also this approach based on decentralized identifiers and verifiable credentials is compatible with the widely used OAuth 2 protocol that is the industry standard for our authentication and authorization. And then we also provide integration with the Web of Things descriptions, and I will present next example of that. Sorry, that the example will come later. So next, now I will describe that what are these two other components that I will discuss today, what they are doing. So first we have a privacy and data sovereignty component, PDS, that basically implements the OAuth 2 authorization server. And this component accepts authorization grant, which can be either a verifiable credential, decentralized identifier, or pre-shared key, and then it returns the authentication token, which is a JSON Web Token, or it could be also a blockchain-based token. And then we have an identity authentication and authorization component, which accepts the authentication token like the one issued by PDS component, or it can also accept the verifiable credential or the DID directly, and then it will provide access to the resource like a IoT device actuation or sensor reading. So basically, like PDS is like a policy decision point, and the IA component is the policy enforcement point for the access control. And now I will present this example that how to integrate this in real world, for example, with the Web of Things descriptions, which are standard way to describe properties of IoT devices. So in the things description file, we can actually provide the information that what kind of verifiable credentials can be used or should be used to access this device. So the relevant fields are highlighted in red. So basically we define that we need to have a verifiable credentials to access this device with a certain context from a certain issuer, and we can have a filter that says that, okay, the credential should also have the device field matching this specific device. And then the SOFIA IAA component would enforce these limitations, and in this way the user will already know from the things description advertisement that what kind of credentials he should use to access the device. Okay, so now we come to the conclusions of my presentation. So I covered two topics today in the context of SOFIA. That first we have IntelliLedger, and which enables better efficiency and privacy, interoperability and high degree of automation, and various novel use cases by allowing usage of multiple ledgers. And then decentralized identifiers and verifiable credentials are emerging open standards that enable self-sovereignty and offer less reliance on third parties, better privacy through selective disclosure, and they can be used for both people and Internet of Things. And they also can be compatible with existing technologies such OAuth 2 or things descriptions. Okay, so this concludes my presentation. Thank you for your attention. And here's the link to our site.
Many thanks, Dimitri, and I want to thank Mirko again for presentation. It seems that in the cluster there are very rich enterprises going on, and I hope that your findings and the kind of enablers on which you are working can really benefit the whole community. I think we have a few minutes left. If there are people from the floor that want to intervene, I just want to tell Dimitri that, as in the case of Mirko, we will get back to him for some information on some dissemination deliverables on which we are working. But I want to give the floor to somebody from the audience that if they want to intervene. I have a question for both of you, just general one. Until when is your project going on? I mean, how much time do you still have left?
It's a 6 months or so until.
Okay, so both of you have still 6 months to go. So now you are really into the kind of more dissemination phase.
Exactly, we are now in the dissemination phase, and regarding the Corona situation, I think there will be a small extending of the project phase, but now we are publishing the stuff and show the stuff.
Yes, and for the Sophia, we are also conducting our pilots currently.
Okay. Alice?
Yeah. You can hear me? Okay, perfect. I don't know if you have read already question also. Dimitri, can you see it?
Excuse me, I don't see a question addressed for me.
I see a question of Marian.
Yes, it's in the chat.
Yeah. I see a question of
Marian. No, it's only for Mirko. Sorry. Yeah, I haven't. Yeah, I haven't. I made an error. Sorry.
So the question of Marian is, what do developers need to get started with their own IoT crawler solution? And it's a second, how do you attempt to meet their needs on GitHub? Thank you very much for that question, Marian. First of all, what we are preparing now are completely ready to run Docker containers. So if you are a developer and you know how to work with Docker and Kubernetes, I mean, that's one skill which will help you to step in. Then you can easily start your first IoT crawler solution by using the container frameworks. That's for the first start, I think the best way, just to learn how it works. And then afterwards, we have the GitHub, and there are GitHub documentation stand for all the particular components which are there. And if you want to deep dive, then of course, currently we have the documentation. We will start now with the webinars to prepare webinars from some certain components. And even for the start. So now I think the next weeks, a lot of stuff will follow up for developer support.
Many thanks, Mirko. Let's see if we have any other question. People can just write on the chat or speak. We can use both ways. In the meantime, just let me announce 2 things. We have already planned other 2 events. One is on July the 10th, which will be about 5G and data protection related issues. This is a kind of hot topic for people involved also in data protection and security, the impact that 5G will have and it's having on it. So we will hear from one EU project, which is 5G Drive. And then we will continue also the conversation that we started on the data strategy that is relevant for many projects which are going on, of course. One American-based research institute, which is based in New York University, NYU, the ANOW Institute, which is artificial intelligence now, has published their submission to the European Commission on the EU data strategy and the white paper and so on. So we will hear from the authors and we will discuss the EU data strategy and artificial intelligence paper from an American perspective. So we will send invitation around for you to join if you want. And Alice has already shared next event for July the 10th in the chat. This is all from my side. I'm giving the floor to Alice to conclude, and we look forward to having you with us during next event. And as far as Dimitri and Mirko are concerned, I thank you very much again, and we will be in touch by email with you, I think this evening or tomorrow. Thank you. Alice, you have the floor.
Yeah, thank you for this great event. And just a little information for all those who would like to receive some updates. Maybe, Pasquale, we can share an alias to the audience or your email in order to keep the contact on. What do you think about it? I mean, if someone is interested.
I'm just adding my email there.
Yeah, perfect. So, for all those who are interested in the next IoT webinar, you can write to Pasquale, and in this way we can keep you updated on the events. Yeah. So we can wait for 5 minutes if someone else has some questions, and if not, we can leave the floor to I don't know, to your afternoon. Thank you.
Thank you, everybody.
Thank you.
Thank you.
Thank you. Bye. Have a nice weekend.